Alright, please put your pencils down, guys. Do not watch this video with a pencil in your hand. Put your pencil down. Today's lesson is about the intersection of circles and lines. So picture a circle and there's a line. We're trying to find the points of intersection. Like this could be 3, 1 and -2, -5. We're trying to find those points. Okay, so obviously this top equation is the circle because you see the x squared and the y squared, and the bottom equation represents the line. Alright, notice there are no exponents. In the line equation, the first thing you have to do is get y by itself. Now that's already done for us, so we don't have to worry about that part. Now normally when we have a more complicated circle equation like x minus 3 squared and then y plus 5 squared, if it was more like this, then I would have to multiply out the x minus 3 times x minus 3, and that would be x squared minus 6x plus 9, and I'd have to do the same thing with the y's. I'd have to do all that first, turn this into general form. But this equation is so simple that I don't have to do that. There are no parentheses being squared. So I can skip to the next step. And the next step is to substitute this expression in for y. So that's what I'm going to do. Easy peasy. So this is going to become x squared plus, now here comes the y squared, but in place of y I'm going to put 3 minus x. Okay, squared is equal to 16. Okay, so that means I've got x squared plus, okay, equals 16, and I'm just going to change colors so nobody misses it. Alright, so I'm doing 3 minus x times 3 minus x right now. Okay, and I'm just going to do the distributive property. So, you know, 3 times 3 is 9. 3 times negative x is negative 3x. Negative x times 3 is negative 3x. And negative x times negative x is positive x squared. Okay? I've still got my x squared plus, and I've still got my equals 16. Alright, cleaning this up a little bit, you see I've got my x squared here. Putting those together, that gives me 2x squared. Alright, negative 3x and negative 3x, that's negative 6x. Okay, and I've got the plus 9 is equal to 16. Alright, let's go ahead and subtract 16 from both sides. So that's going to give me 2x squared minus 6x minus 7. So now it's time to factor this, or we could use the quadratic formula, but if it looks easy, go ahead and try to factor it. So 2x squared can only be 2x and x. 7 can only factor as 7 and 1. This is not looking good. This doesn't seem to be factorable. So I'm going to go back and make sure I didn't make a mistake. Alright, I did not make a mistake, so this is unfactorable. So that means we're going to have to do the quadratic formula. So remember that the quadratic formula is like this. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And of course this is a, and this is b, and this is c. So this quadratic formula becomes x equals, alright, opposite of b, alright, b is negative 6, so the opposite would be positive 6, plus or minus square root b squared. Well, negative 6 squared is 36. B squared minus 4a c, okay, all over 2a. Okay, I'm setting up for my quadratic formula. Now, let's see. Let's do this part under the radical here. So 36, let me just cheat up a storm here. So I've got 36 minus 4 times 2 times negative 7. Okay, and that is 92. Okay, so I've got x equals 6 plus or minus the square root of 92 over 4. So I've got that so far. Let's see what the square root of 92 is. Alright, square root of 92. That is 2 radical 23. Okay, so I've got x equals 6 plus or minus 2 root 23 over 4. Now, because all of these three numbers are divisible by 2, I'm going to do that. Has to be all or nothing, all three or nothing. So that's going to give me x equals 3 plus or minus radical 23 over 2. Okay, just divide everything by 2. So these are the answers for the x values. I think let's go ahead and get the decimal versions of these, because we're going to have to graph it and stuff. So let's do the decimal version. So understand that this means two things. This means 3 plus radical 23 over 2, and it means 3 minus radical 23 over 2. Alright, so let's get these two decimals. Okay, so let's see, 3 plus radical 23 over 2. Alright, toggle it. So we've got 3.897, so that would round to 3.90. Okay, and then the other one, wait, I think that was this one, 3.90. Alright, so that was 3 plus radical 23 over 2. Now we need to do 3 minus. Alright, and that is negative 0.897. So that's negative 0.90. Okay, so these are the two x values that we're dealing with in decimal form. So I'm just going to make myself a little table here. Okay. So I've got 3.90 and I've got negative 0.90. And I need to know the y values that go with these. So basically I need to take these values and plug them in way back into here where I do 3 minus x. And that's where I need to plug them into. Or I can use my calculator. Okay, I'm going to try using my calculator. I'm going to have to be careful. So if I hit the table button and I do 3 minus x, okay, to get this function going. Alright, I hit enter. Now, normally I would just jump in there, but if I do, I'm going to run into this problem where my x values are all whole numbers. You know, they're all integers. and but these x values are decimals. So I need to do something slightly different. So let's go back, hit the table button. I'm going to do this. Instead of leaving it on auto, I'm going to put it on ask x. Alright, that way I can tell exactly what I want. So I want an x value of 3.90. So now I can type in 3.90. Boom! And it gives me the y value of negative 0.90. Alright, I'll give an x value of negative 0.90. Alright, and that gives me a y value of 3.90. Okay, so these are the solutions in decimal form. And okay, and I could have also written them this way, 3.9. I'm going to go ahead and leave off the 0 for now. 3.9 comma negative 0.9 and negative 0.9 comma 3.9. Okay, same thing. So these are the solutions, and that's how you would solve this problem algebraically. Now let's look at this problem graphically and see if we get the same thing. Now graphically, what's the center of this circle? Hopefully you see that the center is 0, 0, because it's just x squared and y squared, nothing being added or subtracted. So I know the center of this circle is at 0, 0. Now what's the radius? Right? Because I have 16 here, that means the radius must be 4. So I should be able to go 4 in all directions. So here, 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 and here. Alright, so I'm going to go ahead and draw the circle now. And it should be like this. Okay, let me clear that out. So here's my circle. I think I'll make it pink. Alright, now I need the line. I'm going to make that green. The line, what was that line again? Oh, 3 minus x. Please understand that the equation y equals 3 minus x. You know, this is like backwards, right? From what we're used to. So I could flip it around and make it negative x plus 3. Now, I didn't change any signs. Just understand that when you move this stuff, the negative sign goes with the x. And this 3 in front, it's positive. So when I switch these, the negative x goes here, and then the positive 3 goes there. Alright, anyway, so this is the equation. And that means the y-intercept is 3, alright, because of that. And then this negative x means it's like negative 1 over 1. So I'm going to go down 1, right 1 from here. Okay, and it'll be like this. All right. So if I go ahead and draw not tangent. If I draw my line, it's like this. Okay. So you can see where the intersections are. Whoa, I didn't mean to do that. All right, my points of intersection are here and here. Okay, now let's see if that matches what we got. we were supposed to have a point at an x value of negative 0.9 and 3.9. So that's very close to negative 1 comma 4, right? Close to that. So negative 1 comma 4, yeah, that would be this point right here. Alright, so that must be our negative 0.9, and our 3.9 is this point right there. And then we were supposed to have one at 3.9 comma negative 0.9. So again, this is very close to 4 comma negative 1. Alright, so if I go over to 4 down to negative 1, that would be here, and this is real close to that. Alright, so this must be our 3.9 comma negative 0.9. Okay, so graphically we're confirming what we found algebraically. So those numbers did not come out pretty, and we had to use the quadratic formula. So I'm really hoping you do not have your pencil in your hand and you're just copying off of me, because it would really be valuable for you to go back and see if you can do this problem by yourself now. Anyway, so that's the end for number 1. Let's go on to number 2. Alright, problem number 2. Okay, once again, y is already by itself. So I can just go ahead and substitute that in. So I'm going to have x squared plus, alright, now y squared. So, but I'm substituting 2x plus 15 in here. Alright, so this is my y squared. And then equals 36. So that'll be x squared plus, and of course I'm doing 2x plus 15 times 2x plus 15. Alright, distributive property, right? So that's going to be 4x squared. 2x times 15, well, 2 times 15 is 30. And then I've got the 1x, so 30x. Same thing again, 15 times 2x, that'll be another 30x. And 15 times 15 is 225. Okay, so putting these together, we've got 5x squared. And putting these together, we've got 60x. And might as well go ahead and subtract this. So 189 is equal to 0. Okay, I'm gonna go straight to the quadratic formula again. This looks ugly. I want no part of it. I want no part of this. Okay, so quadratic formula. So we have A is 5 and B is 60 and C is 189. So X is going to equal the opposite of B, so that's negative 60 plus or minus the square root of 60 squared minus 4 times 5 times 189 all over 2 times 5, which obviously that's 10. Okay, to the calculator. I like to start with the part underneath the radical. So I'm going to do 60 squared minus 4 times 5 times 189. Alright, let's see what's going on. under the hood? Whoa, a negative. Negative 180. Slow down. Okay, that's a problem for me. So I have negative 60 plus or minus the square root of negative 180 over 10. Look, when you have a negative under the radical, that's going to be imaginary, all right? That means as far as this intersection business, as soon as I see that imaginary thing happening, that lets me know that this is going to be no solution. Okay, so this one is going to be no solution. Now let's graph it and verify our no solution. Let's see what no solution looks like. Okay, so 0, 0. So the center is at 0, 0. The radius is 6. All right, see the 36? So the radius is 6. Okay, so that's here, 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 and here. All right, so let's go ahead and draw that circle. Okay. All right, now let's draw our line. Now our line is at, let's see, y equals 2x plus 15. That's pretty far off the grid. I have to do my best. Okay, it says y equals 2x plus 15. All right, so I'm just going to extend this line. Maybe I'll cheat and make it a little cleaner. Okay, you just do your best. So I need to get this up to 15. So let's see. So we're going 1, 2, 3, 4, 5. Okay, so this is 15, right? 11, 12, 13, 14, 15. Okay, so this is going to be my y-intercept up here at 15. Okay, now this slope is 2 over 1. So that would be like up 2 over 1. All right, which means I actually need a couple more little lines in here. So up 2. Okay, this is a little tricky because it's off the grid, but we're going to make it work, people. So if I go up 2 over 1, okay, that'd be like right here. Obviously, we need to get back down into this area, so I'm going to go down 2, back 1. So that'd be down 2, back 1. All right, should be about here. Then I go down 2 again and back 1. Okay, that puts me there, and now I go down 2, back 1, and thank goodness I'm back on the grid now. So down 2, back 1, down 2, back 1, down 2, over 1, down 2, over 1. Okay, so do you see what's happening here? All right, this line is cruising right past this circle, but it's not touching it. All right, that's why there was no solution, because there is no intersection between this line and this circle. All right, so that's why. And again, algebraically, you'll know it because first of all, it will be unfactorable. And second of all, when you try to use the quadratic formula, you'll get an imaginary number. If you try to type this whole thing in your calculator would have said domain error, domain error. And that also would be telling you no solution. All right, this one looks like it's going to be a little bit tricky. First thing we have to do is get y by itself. So, let's subtract 4x from both sides. So far that gives us 3y is equal to negative 4x plus 3. And then we shall divide everything by 3. Okay. So, kabam. So what I'm going to have now is y equals negative 4 over 3x plus 1. Okay, so far so good. So that's the y equation. That's the equation of the line. Okay, now this is ugly. So eventually I'm going to have to plug this into to the other equation. But this time we will have to actually go ahead and rewrite this in general form. We have to multiply all this out. So x plus 4 squared means x plus 4 times x plus 4. Alrighty, y plus 2 squared means y plus 2 times y plus 2. Alright, if you multiply all this out, doing the double distributive property, you're going to wind up with x squared. Alright, that's plus 8x plus 16. Alright, the 8x came from the 4x outer and then the 4x inner. Okay, and then similarly over here I'm going to get y squared plus 4y plus 4 is equal to 25. Okay, now what? So I'm just going to rewrite it in general form. So this is going to be x squared plus y squared plus 8x plus 4y. Okay, what I haven't done yet is the 16 and the 4, so that's plus 20 is equal to 25. Okay, subtract 25 from both sides, and you've got x squared plus y squared plus 8x plus 4y minus 5 equals 0. So fine, this is the general form of the circle equation. So we needed that. So now we will take this y expression and substitute that. So it's going to be ugly because it has the fraction in there. But we have to deal with it. So we're going to put it in here for this y, and we're going to put it in here as well. Alright, let's see what this craziness looks like. Okay, so I've got x squared plus. Alright, next comes y squared. So I'm going to do negative 4 over 3x plus 1 squared. Okay, and that's plus 8x plus 4 and now this is going to be negative 4 over 3x plus 1. Alright, it's 4y, so 4 times all this, and then minus 5 equals 0. Okay, man, this is what I have to work with. So let's focus on this part right here. I'm just going to squeeze this in here. So I'm going to have to do negative 4 over 3x plus 1 times negative 4 over 3x plus 1. If I do that, alright, and doing the same thing like you always do, negative 4 over 3x times negative 4 over 3x is 16 over 9x squared. Alright, 4 times 4, 3 times 3, it's 16 over 9. And then when I do it times 1, I'm just going to get negative 4 over 3x. Okay, it'll be the same thing when I do 1 times negative 4 over 3x. I get another negative 4 over 3x. And then of course 1 times 1 is just 1. So all of this that I have is all this right here. That's what I'm doing. Okay, I can put these together. And I know this is going to be negative 8 over 3. Okay, now if you don't know where I'm getting that from, then you can just use your calculator. Okay, negative 4 over 3 minus 4 over 3. So that's negative 8 over 3. Okay, when I put these together. So that means I have 19, I have 16 over 9 x squared minus 8 over 3x plus 1. Okay, that's all of that is just this one part of the equation. Alright, I just stopped to do that. Now I need to put all of that back into the normal equation. Okay, I'm not sure if I'm even going to have room for this. So putting it back in, so I have x squared plus, and then I have this. So here's where I just go ahead and put it in. You know what, maybe I'll stick it up on the same level. That would be smarter. Okay, I haven't been bringing down the blue stuff, but I'm going to bring down the blue stuff now. Okay, so I'm going to have x squared plus this. And then I'll have plus 8x. Alright, now I need to do the distributive property here. 4 times 4 is 16, so that's going to be negative 16 over 3x plus 4, alright, distributing, and then your minus 5 equals 0. So I'll clean this up as much as I can. Alright, so putting these together, treat this like it's a 1. So I'm going to do 1 plus 16 over 9. Alright, that's 25 over 9. So I'm going to have 25 over 9 x squared. Okay, now I need to put these x's together. I have x's here, here, and here. So I'm just going to add all of these things. Give myself as much room as possible. So, in fact, let me slide this over to here. Okay, so I'm just doing, whoa, opposite of what I wanted. Okay, so I'm doing these three things. So negative 8 over 3. So negative 8 over 3 plus 8 minus 16 over 3. Whoa, I missed. 16 over 3. Okay, so that's all three of these things. And that is 0. Well, that's pretty cool. So that means that all three of these things cancel each other out. Gone, gone, gone. Alrighty. Okay, that was makes things easier. So now I'm going to focus on the constants that are left. So focus your eyes on this, and this, and this. Okay? 1 plus 4 is 5, minus 5 is 0. So guess what? Those are going to cancel out too. Wow, everything canceled out. Alright, so I really just have the 25 over 9 x squared is equal to 0. Okay, that's what I have. Okay, this is a strange problem. So I'm just going to divide both sides by 25 over 9. Or you could think of it as multiplying by the reciprocal. Doesn't really matter. You could think of it as multiplying by 9 over 25 if you want. Either way, so these are going to cancel out. 0 times anything or 0 divided by anything is 0. So I'm going to wind up with x squared equals 0. If you take the square root, obviously x is equal to 0. Okay, well, we need the y value that goes with that. So the x value is 0. So let's look back, because I'm trying to think of in terms of a table, like x, y. And so far I've got the 0, I need the y that goes with it. I'm going to need the equation. Remember, it was negative 4 over 3x plus 1. Alright, remember that. Y equals negative 4 over 3x plus 1. So that would mean y would equal negative 4 over 3 times 0 plus 1. So that would mean y equals 1, because the 0 part goes away. Okay, so that would give us the point 0, 1. Now, we're only getting one solution, which means this must be a tangent line with only the one point of contact. So let's graph it and see if the graph matches what the algebra is telling us. So looking back at the original equation, what is the center of the circle? The center is negative 4, negative 2. And what's the radius? The radius is 5, based on that. Alright? So, let's graph, guys. So, negative 4, negative 2. So, that would put the center right here. Now, if the radius is 5, that means we're going to go 5 in all directions. Okay, so let's draw this circle. Alright, so there's the circle that we're dealing with. Now let's draw that line. Remember the line? It was y equals negative 4 over 3x plus 1. Let's graph that now. Well, you see the y-intercept of 1. Well, kabam, that's going to be right there. All right, the y-intercept is a point of intersection. And then I'm going to go down 4 over 3 because of the slope. So that would be down 4 over 3, repeat, repeat. Okay. And up 4, back 3, repeat. Okay, so there's your line right there. Okay, and just like we thought, we're coming up with that one point of intersection, which is a point of tangency. All right, our line turned out to be a tangent line. And you see that the point of intersection is the point 0, 1. And looking back at our work, that matches what we got after we did this crazy amount of work, 0, 1. Okay, so there, that's how you solve it. algebraically and graphically. Alright, last one. I'm hoping this one comes out nicer than the other two, because that was a mess. Okay. Well, this one, y is already by itself. And this one is already in general form. Well, pretty close to it. So, I can just go ahead and do the substitution. So that's going to give me x squared plus, and then negative 3x plus 1 squared is equal to 28. So that'll be x squared plus, and then I'm doing negative 3x plus 1 times negative 3x plus 1 is equal to 28. And that's going to give me x squared. So as I do my double distributive property thing, negative 3 times negative 3 is 9, so that's 9x squared. Negative 3 times 1 is just negative 3. Same thing here, 1 times negative 3x is negative 3x. 1 times 1 is 1, equals 28. So putting these together, that's going to give me 10x squared. Treat that like a 1. Putting these together, of course, I have negative 6x. Subtracting 28 from both sides, I have negative 27 is equal to 0. I'm going to use the quadratic formula. If I glance at it and it looks like a challenge, I find it easiest to go straight to the quadratic formula. A is 10, B is negative 6, C is negative 27. The quadratic formula says x equals opposite of b, so positive 6, plus or minus square root. Then it's b squared minus 4ac. So b squared, so it's 36, minus 4 times a times c. Alright, all over 2a. Well, 2 times a is 20. Alright, then I like to put the part under the radical in my calculator. I'm failing right now. Okay. That's all I wanted to do. Did it have to be that difficult? Alright, so I'm doing the part under the radical. So that's 36 minus 4 times 10 times negative 27. Okay, that's 1,116. So that's 6 plus or minus square root of 1,116 over 20. Okay, let's see what the square root of that is. So the square root of 1,116. Ooh, that's some ugly decimal. Well, that means that's the end of the line in terms of a nice pretty answer, which makes me glad I didn't try to factor it, because that means it was unfactorable. So I'm going to go back and just type in this whole thing then, and because we're just going to get a decimal. Now please remember that this is really two things. It's 6 plus radical 1,116 over 20, and it is 6 minus radical 1,116 over 20. So we're going to get two different answers here. Okay, so here I go. 6 plus radical 1,116 over 20. Okay, that comes out to be 1.97. Okay, very close to 2, obviously. And the other one, if I do the minus version, alright, normally I like to just come up, highlight this, hit enter, and then just change the plus to a minus. find that to be convenient. So I get negative 1.37. Okay, so these are my x values. So I'm going to think of this as like a table, x and y. So I have negative 1.37 for my x, and I have positive 1.97. So I need the y values that go with these. Alright, so I'm going to use the table feature to get these y values. Alright, type in your y equation, which was negative 3x plus 1. Alright, but instead of letting it be auto, like it usually is, change it to ask x. If I can get over there. Change it to ask x instead. Okay, so that way I can tell it exactly what x values I want to use. So I want to use negative 1.37, so negative 1.37, and that gives me 5.11. Alright, and I want to use 1.97, and that gives me negative 4.91. Alright, so these are my solutions. I'm going to write them as ordered pairs, negative 1.37 comma 5.11 and 1.97 comma negative 4.91. Okay, now let's go graph it and see if we were right. Alright, so let's go ahead and do the graph now. Well, x squared plus y squared equals 28. That means that the center is 0, 0. Okay, so the center is 0, 0 because it's just x squared and y squared. What about the radius? Whoa, okay, well the radius is going to be the square root of 28. We're going to need a decimal if we're going to try to graph this though. So the square root of 28, let's check it out. Square root of 28, that's going to be 2 radical 7, which as a decimal would be 5.29. Alright, basically 5.3. Okay, so this is about 5.3. So let's graph based on that. So 0, 0 is our center, and we'll go a little bit more than 5 in all directions. Okay, so here's 5, so 5.3 might be about here. Here's 5. Here's 5, so there's 5.3. Oh, let me do this one too. There's 5, so 5.3 would be somewhere around there. Okay, and let's draw our circle. Alright, I know you wish you had a circle tool like I do. Okay, this is 5, 5, so this will be okay. Do that. I usually make these pink. Alright, so there is our circle. Now let's graph the line. Where is that line? I forgot about it. Oh, I see. Y equals negative 3x plus 1. So the y-intercept is 1. So we'll start here at positive 1. And then the slope is negative 3 over 1. So that's down 3, right 1. So we will go down 3, right 1 over and over again. So down 3, right 1, down 3, right 1, down 3, right 1, and I'll continue in the other direction. But in the other direction, it's like up 3, back 1, up 3, back 1, up 3, back 1. Okay? So our line is looking like this. Okay? So now let's look at our intersection points and see how they compare to what we got algebraically. See if it matches up. So we're seeing an intersection point here. Okay? So to me, this looks to be about, it's -1 point something and 5 point something. Okay, so look at our first point right here. -1 point something and 5 point something. Alright, so this must be our -1.37 and 5.11, comma 5.11. Now this one seems to be something very close to 2, -5. Okay, and then look here. This is very close to 2, -5. Very close. Okay? And yeah, so this intersection point is right here. And it's very close, not exactly, but it is 1 point. So this must be our 1.97 and -4.91. Yeah, in general, see, if all we had was the graph, we would be able to estimate, but we wouldn't be able to come up with this kind of accuracy to the decimal point. All right, so we really need to solve things algebraically when we want a solid answer. Now look, I know these problems that I did in this lesson were difficult, and my fear is that you had a pencil in your hand and you copied off of me. I'm proud of you for watching the video at all in the first place. But it's very, very important that you go back and do these problems by yourself. Otherwise, when you see this on the test, you will choke and freeze and fail. And I don't want that. So please, if you've been copying off of me, take out a blank sheet of paper and go back and see if you can do these problems on your own. It's so important. I cannot overemphasize that. Alright guys, that is the end of this lesson. I hope it was helpful, and I will see you on the next video.